Today we're looking at the greatest common factor and difference of perfect squares. The first thing we want to look at is kind of the opposite of our GCF, and that is we're going to distribute. So our first example, we have a times 3a plus 7. So again, to distribute, we're going to take that a, multiply it by both. That's going to give us 3a squared plus 7a. On our next, we have negative 2m times m squared plus 6m minus 1. Yeah, we're going to distribute that negative 2 to each thing on the inside of our parentheses. So it's going to get us negative 2m cubed minus 12m squared minus or plus 2m. Then our last, we got 4 x cubed y times x squared minus 2y. Again, distribute, even though we have two variables, we just treat it like we always have. So we got 4 times a 1 gives us 4x cubed times x squared. We add our exponents together. So that's going to give us x to the 5th. We don't have a y there, so we just have our y minus 4 times 2, 8, x cubed stays x cubed, and we get y squared. Now, why did we do that? Again, we're going to be looking at greatest common factors today, and GCF is kind of the reversal of what we just did. So when we're looking at polynomials, what factoring is, we're taking something from its simplest form, so standard form, and we're breaking it down into its components. So we're going to be going the opposite direction. We're going from here back to this, breaking it down into factors or things that multiply together to get us our standard form. Some polynomials cannot be factored, and we call those prime. So just like prime numbers, we have 7, 5, 3, 2, all of these are prime. We cannot factor those. Their factors are just one in themselves. Same thing with polynomials. It's like x squared minus 4. We can factor that. We can break it down into two things. Whereas an x squared plus 4 cannot be factored. That would be considered a prime polynomial. Okay? And we're about to do this here. So, here goes the thing. Let's look at our examples that we have down here. So our first example, again, we're going GCF. So the way we factor these with our greatest common factor is we want to look at our numbers first, or our coefficients, see if we can divide by any numbers. So in this case, we only multiply by a. 3 and 7 are both prime. We cannot take out a number. So then the next thing we would look at is our variables. Do all the terms have variables in common? In this case, a is common. So we can divide both of those by an a and pull it out to our GCF. We can always, after taking out our GCF, distribute like what we just did to get back to what we started. So let's kind of do a few of these together. Our first one, we have 3x plus 12. And again, the first thing we want to look at is, do we have any numbers that both of these coefficients where numbers can be divided by? Their greatest common factor. 3. So we can take out a 3. The next thing is we would check for variables in both of our terms. We have an x here. We do not have one there. So 3 is going to be our greatest common factor. We divide these both by 3. So 3x divided by 3 leaves me with an x, plus 12 divided by 3 leaves me with 4, and there we've done factor. Again, you can always check your work. Take 3 times x gets 3x, 3 times 4 gets 12. Go back to where you started. So number 2, we got 7y minus 7. What would be our greatest common factor? 7. That's all we can take out. 7y divided by 7 y. Negative 7 divided by 7 is negative 1. So number 3. Negative plus 36 and what would be our greatest common factor? So 8 doesn't quite go into 36, but 4 does. We can divide them both by 4. Now in this case, they both have variables. However, those variables are not the same, so we cannot take out either of those two variables. So we can divide by 4. So 8m divided by 4 leaves me with 2m. And 36 divided by 4 leaves me with 9m. And again, you can always check. Do these two numbers have anything in common that you can divide by 2 and 9? No. So we know we did take out that greatest common factor. Okay. If for some reason we took out 2, we didn't recognize that 4 was the greatest common factor, we took out a 2 instead, that would leave us with 4n plus 18n. And we can just repeat the process again. So I could say, well, I didn't take out the greatest common factor. Both of these are divisible by 2. So I'm going to take out another 2. This first 2 will just come out. We're going to multiply it by the second 2 that we're going to take out. Right? Divide them both by 2. Then you just multiply those front numbers. You end up with that same result. So even if you don't take out that greatest common factor right at the start, so you did this instead, you took out a 2, then you can just continue that and take out a 2 again. Okay? You end up with that same result. Those two values that you took out, multiply them together. There you go. There's your answer. So that is our greatest common factor. So pick out some numbers from the back page. What you want to do? 14. We got 18. Squared, minus 48. Okay. First thing we want to look at is our numbers. We've got 18 and 48. What is the greatest common factor between those two? Again, kind of think about it. 1 times 18 is 18. 3 times 6. That's about it. 48. Of course, you have to be 1 and 48. You got what? 2 times 24. 4 times 12. 6 times 8. So 6, right? So we can take out a 6 from both of those. So then we look at our variables. Whenever we have different powers, we can only take out the lowest degree, the lowest power that we have. So in this case, we have an a squared and an a. So the greatest common factor among those is a. When we look at our b, it's just going to be b. And same thing with our c. We have a c squared and a c cubed. The biggest we can take out is our lowest, that's c squared. And then we do our division. So 18 divided by 6 gives you 3. A squared divided by a leaves us with 1a, or a to the power of 1. Again, we subtract our exponents when we divide. B divided by b, those cancel out completely, and c squared divided by c squared, those cancel out. So we say minus 48 divided by 6, 8. A divided by A cancels out. B divided by B cancels out. C cubed divided by C squared leaves us with C. There's our end result. Again, you can always check your work, multiply it right back out. You should end up with the exact same thing that you started with. Okay. Any others on there that you need? 16. We got 9r squared minus okay, so first thing, look at your numbers. We've got 9, 18, 24. So 3. Right? 9 goes into 18, but it doesn't go to 24. The only other factors of 9 are 3. We take out a 3. So we look at our variables. We've got R, R, and R. And the lowest power of R is to the first degree, so we can take out an R. And then these two have S's, but this one does not, so we cannot take out the S. So we can just take out our 3R. It's our greatest common factor. So we divide. So 9 divided by 3 leaves me with 3. R squared divided by R leaves me with R. Minus 18 divided by 3.
Well, on the C, it's R to the A.
Is that right? No, R to the 8. That's going to change it to R to the 8 divided by R is actually going to give us R to the 7. Going on. R squared divided by R leaves us with R, and our S just stays the same. Minus 24 divided by 3. 8. R divided by R cancels out, and we have S squared left over. Again, you can always check. None of these numbers can be simplified. We don't have variables in all sense. So there we go. That's as much as we can do. Any others? You guys want some time to work on this, or do you want to keep going with the notes? I'll give you some time to work on greatest common factor, then we'll come back and look at our perfect squares.